Hello class, this is CSE 4410, Chapter 7. Alright, for CSE 4410, Sections 1 and 2, Spring 2024, by the time you're watching this, there's a good chance that all of your assignments, including your midterm presentation, all those should be graded except for the two latest programming assignments. So I want you to double check your grade, make sure everything looks right. If there's any discrepancies or that something is missing, contact me about that so I can correct your grade. Okay? Alright. So now we are looking at Chapter 7 today. And for this video, I'm also going to show some of the slides that's part of your presentation, PowerPoint presentation for this chapter. So Chapter 7, we are adding in a UI to our game, where, well, specifically this builds off of the first-person shooter from Chapter 3, but we can adapt this to any project that you want. So even if you don't have the Chapter 3 project anymore, you can still follow along with what we have here. You're just going to have to do a few tweaks so that it works on, well, whatever you have in your project. By the way, and this is for Spring 2024, Sections 1 and 2, your midterm, and I noticed that a few of you added a UI already, which is actually good because, well, you're a little bit farther along than what I have already here. Anyway, your final project will have you have the choice of either continuing the midterm project that you already had, or you can make your own game with the same group that you are already in. All the material that we are looking at henceforth is going to be aimed more at talking about how you can add to your game. So, UI to your game. Interactable objects, which is actually in the next chapter, and how to add sound to your game. Okay, so Chapter 7 is how to add a UI to your game. There are a few similar looking terms. UI is user interface. GUI or GUI, that is a graphical user interface. UI, user interface, that is how the computer shows things to the user. And at the absolute least, it's going to be text, much like a Linux terminal. Graphical UI or GUI refers to the graphical elements of a user interface. And we tend to use the terms UI and GUI interchangeably, even though they're not really the same term. Similarly with the term HUD, it's a term that's borrowed from like military terminology, where we have UI elements superimposed on top of, in our case, the game view. Anyway, I'm just going to proceed on with Section 1 of the PowerPoint slides. There are two modes to a UI. There are two UI modes in Unity. I should also mention that for this chapter, and there's a little bit of abuse of terminology here, I'm going to use the terms UI, GUI, and HUD to refer to the same thing, even though in other contexts they're gonna likely refer to different things. But for our purposes, they're gonna refer to the same thing here. So if I say GUI when I mean UI, or HUD when I mean UI, for our purposes, they're the same thing. So there are two modes. There are two GUI modes There are two GUI modes in Unity. The first one is called immediate mode GUI, where we use draw commands that are called every frame to draw our UI. The other one is called retained mode UI, and this is the UI mode that we expect when we think about putting a UI into Unity, where you design the appearance of the UI without having to play the game to see what it looks like. That's the thing about immediate mode GUI. You need to play the game to see what it looks like. Retained mode, we can see what it looks like without having to play the game first. So those are the advantages of immediate mode GUI and retained mode GUI. This chapter will have us focus on more on retained mode GUI, but I will go back to immediate mode GUI in the following chapter. That's chapter 9. In fact, remember back in chapter 3, we had to add a crosshair, and the code for that looked like this on GUI, and then inside of that, we had GUI.label where we had to pass in the bounds for a rectangle, and then text, which is just an asterisk. Well, that was an example of immediate mode GUI, where we use these GUI draw commands, GUI.label in this case. We use that to draw a label onto our screen, and that label was our crosshairs. Another example is where if you type this code into the onGUI method. Oh, and by the way, this code is the Ray Shooter script. If you added in this code here, you can add in a button that says, click here for free iPod. Now, one interesting thing about GUI.button, that is a method that returns true if that button was clicked on during that frame. So based on that, we can do stuff. In this case, we're just printing stuff to the debug screen. We can just simply say, button has been clicked. But we can do other things based on whether that button was clicked. So yeah, this is an example of immediate mode GUI, and it's perfectly fine if you just want to make a quick user interface. But if you want a more elaborate user interface that has, for example, the ability to rescale, the ability to resize itself based on how big the screen is, then we're going to want retained mode. So the rest of the chapter is going to focus on retained mode. By the way, if you are following along with the original chapter 3 first-person shooter, go into the start method right now and comment out these two lines of code. Cursor.lockState equals cursor.lockMode.locked, and cursor.visible equals false. You'll need to comment out that code because these two lines of code, they effectively disable the cursor. Well, it locks the cursor to the screen, and it also hides the cursor. And with that, we can't really click on the button that we made here. So, I'm actually gonna pause. I'm actually gonna try out this code here right now, just to show you what it looks like. Okay, so here is our Ray Shooter script. I've went ahead and commented out these lines of code. So now we go to the onGUI method. I'm going to type in that code that adds a button. So, let's try it out. If GUI.button, I'm gonna pass in new rack 10, 10, 180, 20, comma, click here for free iPod. And then I can say debug.log button has been clicked. Let's try it out just real quick. Alright. Save that, and again, this is all in the Ray Shooter script. Once again, I had to comment out these two lines of code just so I can actually click the button. Alright, let's try it out. I'm gonna click play, and now it's gonna appear really small for me because I am working on this project on a 4K monitor. So everything's gonna appear small for me. For you, if you're working on this on an 1080p monitor, you should be fine. But now we have a click here for free iPod button here, and if I click on it, click, 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 click. Well, for one, it's actually gonna shoot a sphere also, but that's because, well, that's actually one annoying thing we'll have to take care of, because this first-person shooter fires a bullet every time we click, and we don't want it to fire a bullet if we click on UI elements. So, I'm just gonna try to click on the sky here. Try my best to click on the sky. Click, 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 click. Click, 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 click. No. Try again. Click, 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 click. And when I go to the debug console, look at that. Button has been clicked. Alright. So yeah. That is an example of an immediate mode UI button. Now we're gonna mosey on over to working with retained mode. So yeah, let me just pull up the slides again. Immediate mode has the advantage of we can create a UI. We can create UI elements rather quickly. But retained mode, we have the advantage of we can see what the UI looks like before we play the game. Not necessarily how the UI works, because we have to play the game for that, but we can see how it looks, and we can tweak it without having to play the game every single time you want to see those changes. So 7.1.2, we can start with a sketch of what our UI is going to look like. So there are 3 parts to this. The first part is a score display, which shows us how many enemies we've killed in our first-person shooter. The second thing is a settings button that opens up our third thing here, a pop-up window, where the pop-up window is going to have a few things of its own. First, it's a close button because, well, we opened this thing and we want to close it. The second thing is a field where we can type in a player name, our player name. And the third thing is a speed slider where we can use that to change the speed of the enemies and the player. Which is a little weird because you'd expect this setting to be a thing you change before you play the game. But this is just something that we want to try out just for learning purposes, so it's probably fine. Okay, so you'll need to go to the corresponding GitHub. You'll need to go to the GitHub repo that is the companion GitHub repo for the textbook, and you'll need to download 4 sprites. They are close.png, enemy.png, gear.png, and popup.png. Download those, and then you'll need to import them into the project. I'm gonna stop this right here and get to that. Right, so now we have our 4 buttons, 4 icons here. I guess I shouldn't really call them icons because we're gonna be using these things for different purposes. They're sprites. Much like the sprites in our 2D game. However, in a 3D project, when you import images like this, they are going to default to textures, and we don't want that. So, I'm just gonna control-click all 4 of these sprites, and in the inspector, I'm gonna change texture type to sprite, 2D, and UI, and click apply. There we go. Okay, so now we have these 4 sprites that we can use for our UI. Our next thing is to add what's called a canvas. So I'm going to right-click in the hierarchy, UI, canvas. So this canvas object is huge. Look at that. And that's because 1 unit in Unity corresponds to 1 pixel on the canvas. This canvas is actually as big. It's as big. The size of the canvas depends on how big it is, how big the scene viewport here is. In fact, if I change the size of it, the size of the canvas in the game also changes. So really, really far outstretched, and then squish it really thin, and it's a little bit hard to see, but yeah, the UI elements in here, well, the canvas itself is really squished. So I'm just gonna stretch that back out, and now we can get to work on adding a few UI elements to this. Okay, there are a few more settings that we can change as well. One of them is, let's set this to pixel perfect. That way, if we have pixel art, if you have pixel perfect checked, there won't be any blurring between two adjacent pixels. So I'm just going to set that. And something specific to my recording setup is I am working on this on a 4K monitor, and Windows has an upscaling feature where everything is upscaled by 150%. So this is specific for my setup. I'm going to change scale factor to 1.5. That way, everything, all the UI elements that I import, they're going to be upscaled by 1.5. But you don't have to do this unless you also have a high resolution monitor like I do. So if you have like a 4K monitor also, you're going to want to set, you're going to have to go to the canvas scaler and set it to 1.5. Yeah, that is one consideration for making video games on different size screens, is how do you get the UI to scale properly on different size screens? Because we have 1080p monitors, that's 1920 pixels by 1080 pixels. That equates to like 2 million pixels. 4K is 4 times that, but that's not why it's called 4K. It's called 4K because 3840 runs to 4000 or 4096, whatever. Okay. It's called 4K because, as I said, it runs to 4096. But I have a 27-inch 4K monitor, and as I said, this is something that I have to do, and you might need to do this also. If you also have a 4K monitor like I do, or you're going to have to support 4K monitors as well. It's really a good idea to try to make your game support as many devices as possible. And one quick and easy way to do that is to change the scale factor. So I'm going to set it to 1.5. This is a canvas scaler component that is part of the canvas by default. You don't have to change this unless you need to. But I'm going to proceed anyway because all of these instructions will work regardless of the scale factor. Okay, I'm going to add 3 UI elements. That is an image, a text, and a button. Now, I've actually done this already, but there is one package that will be imported whenever you add a Text Mesh Pro object for the first time, and it is this. So back in chapter 5, I had you make a memory game where we had to use a text element that required something called Text Mesh Pro. So if you have a pop-up that looks like this, TMP importer, this appears to be the first time you access Text Mesh Pro. As such, we'll need to add resources to your project that are essential for using Text Mesh Pro. Just click Import TMP Essentials. You do not need to include TMP examples and extras. So yeah, that's one thing you'll need to do. If you are prompted to import TMP Essentials, just import it. I've already done this, so I don't have that pop-up appearing. So now we can move forward with positioning these UI elements. Remember, one unit in Unity corresponds to 1 pixel on the canvas. So, as I said, this is huge, but it's probably huger simply because I have a 4K monitor. So, the entire game takes place on this little itty bitty square down here. Really hard to see because it's so small. Anyway, I want to set this to 2D view. That way it's easier to move these objects around. I'm also going to use the move tool so it's easier for me to move these things around. So I'm going to try to move this image to the upper left-hand corner. I'm also going to move the text to the upper left-hand corner here. I'm finally going to move the button to the upper right-hand corner because that's how it was set up in that sketch from earlier. So now, if I click on the game view, we have these 3 UI elements. But there's a problem. Where'd it go? Where'd the UI elements go? Well, the problem is we did not set our anchors properly. So, as I was moving these UI elements around, and I'm gonna have to push this back down. You notice how there's a little X here? Well, that's not an X. That's actually an anchor. And that anchor tells us where on the screen our UI elements are going. So, if I click on these crosshairs here, so I have the image selected, and I clicked on these crosshairs. So this thing here pops up, and these are anchor presets. These are positions onto which our UI elements will be anchored to. So if I choose the upper left-hand corner for the image's anchor, and I do the same with the text elements anchor, upper left-hand corner, and I try to resize the game now. Well, the settings button is gone, but the text element and the image element, they are staying in place. That's good. Well, now we can easily support wider screens, because there are ultra-wide monitors out there with a resolution such as 2560 by 1080 and 3440 by 1440. I've yet to see a 5120 by 2880 monitor, but that is also ultra-wide. At same proportions as like 2560 by 1080. It's like 4 of them arranged in a square. I guess it's a rectangle, but moving on. I'm also gonna change the anchor of the button here to be the upper right-hand corner. So now, if I resize it, the UI elements are basically staying in their place. They're not moving off the screen. Oh, by the way, we have a text element as part of our button. That is by default, but our settings button is just a gear. We don't really need text for that, so I'm just gonna delete that. So now we have our UI all set up except for the pop-up window. We'll get to that later. Now what I can do is I'm going to select the image here, and I'm going to open up this image component. There is a field for a sprite. I'm going to drag and drop the enemy sprite into here. But it's the wrong proportions. That's because it was the size of whatever the default sprite was. Give me a minute. Where was I? Oh yeah, the image that we just put into this field was basically crammed into the shape of that default sprite. But it's an easy fix. Set native size button. Click that. There we go. Now, it's a little bit smaller than we want, but we could just upscale it if we need to. Say, scale, change the scale to 1, 2, maybe like 2. And that will work too. It's a set. And once again, I am changing the scale factor because I'm on a 4K monitor. Maybe I'll have to set it to 2. That works, right? Okay, let's just roll with it. I will need to move a few elements some more, so maybe like this. There we go. This is just to make sure that everything that you see here is perfectly visible on YouTube. By the way, I say this is a 4K monitor, but if you look at the speed settings, like at the corner down here, yeah, it's not the speed settings, but rather the resolution settings. It maxes out at 1440p, but that's because I'm recording at a 1440p resolution. So yeah, I say it's a 4K monitor, but I'm downscaling things to 1440p. It's just so it's easier to upload that way. Okay, anyway. Now we can change the sprite for our button. So I'm just going to drag and drop this gear sprite into the source image field here, and it's also squished. Set native size, there we go. Yeah, it's the set native size button. So if the proportions are off, all you gotta do is click set native size. There we go. Okay, so now we can continue work on our UI. We've already, in fact, let me just put up the slides. We positioned our 3 UI elements. We've deleted that little bit of text on the button. We've also assigned the enemy and gear icons. And one thing we can also do is change the text on our Text Mesh Pro text label. Basically, we can just change the font size, font style, and if we have font assets, the font itself, we can change that to our liking. I already talked about the anchors on the these UI elements, so that way if we resize the game view, they won't like fall off the screen. Okay, so now we are in section 7.3. This is section 3 of chapter 7. If you have not commented out those 2 lines of code, cursor.lockState equals cursor.lockMode.lock and cursor.visible equals false, comment those out now. That way we can play around with the buttons to see that they work. Also, we're going to need to make one other change in our ray shooter script. And I'm going to show that right now. I'm going to open up the ray shooter script right now. So previously I added the button, click here for free iPod, and I had also commented out these 2 lines of code. I'm going to make a change to this code, and it looks like this. Remember, if input.getMouseButton down, that method, the get mouse button down. Input.getMouseButton down 0, that is listening for when the user presses down the mouse button from the unpressed state to the pressed state. So basically when the user clicks the left mouse button, it's going to fire a bullet and place it somewhere on the screen. But we don't want that to happen if the user is clicking on this button here or any other user UI element. So I'm going to try to click here, but it's also firing our gun. So not what we want. So easy fix. All you got to do is add a few more lines of code. So you actually need to add this first. You need to add Unity Engine.event systems here, and then if get mouse button down 0, I'm gonna add and we can continue this on the next line, not event system dot current dot is pointer over game object, left and right parenthesis. So now we're only gonna fire a bullet if the user is clicking the left mouse button and the cursor is not over a UI element. Let's try it again. Position the cursor so that it's over the gear and it's pointing at a wall. Click, 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 click. And we don't have bullets firing on the screen. But it will if it's anywhere other than the UI element here. Let me just do a test. I'm trying to do a test where I try to click the... It doesn't quite work for the immediate mode button here, but it does work with retained mode buttons. So that's just one thing to keep in mind. Alright, so now we have a button, but you saw me click the button, but it didn't do anything. Let's have the button do something now. Okay. Okay, so section 7.3.1 has us do the following. So, UI interaction, we're gonna program it like this. We're going to create a UI object in the scene. We already did that in the form of our button. Our next step, we are going to write a script, and there's going to be a method that we're going to call when that UI object is operated on. Next, we're going to attach that object to something in the scene, and then we're going to link a UI element to the object with that script. I'll show you what that looks like right now. Well, basically what we need to do, we need to write a script called UI controller, and then we're going to write a method that eventually it's going to make our settings pop-up appear. But for now, we're just going to have it write something to the debug console. So, this is the code that we're going to write for our UI controller. And that UI controller is going to be attached to the same object that our scene controller is attached to. So I'm going to create a new script, create C# script, UI controller. I'm going to click on the controller object in the hierarchy, so that way I can view it in the inspector. Then I'll just simply drag and drop the UI controller from the project view into the inspector, because that works too, by the way. So that's just an alternative to dragging and dropping things onto game objects in the scene. You can just drag and drop from the project view into the inspector, because that also works. I'm now going to edit the UI controller script. I'm going to add the following code. So after using Unity Engine, I'm going to add using PM Pro. I'm going to add a private field, serialized field, TMP text, score label. I'm going to remove the start method because I actually don't need that. And in the update method, I'm going to write score label.text equals time dot realtime since startup dot toString left and right parenthesis. And then I'm going to add another method called onOpenSettings. So public void on open settings. No parameters being passed in. So debug.log opening settings. So when this method is called, eventually we're going to write code that makes the settings pop-up appear. Right now, it's not going to do that. It's just going to say something in the debug console. So this script is now attached to the controller object that also has the scene controller. Why do we have two separate controllers? Couldn't they just be the same object? Well, they can if the game is small enough. But for a larger game, we do something called separation of concerns. So the scene controller is, in this case, in charge of enemy spawning. The UI controller is in charge of displaying stuff to the UI. The idea behind separation of concerns is that way if one system breaks, the other systems can just keep working as normal. So now we have a text field here. This text object in the hierarchy is this here. So let me go back to the controller. select that in the hierarchy, and then I'm going to drag and drop the text TMP object into this field here. Now let's run it. So click here for free iPod is still showing up here. I can just comment that out. We can just comment that out now since we don't really need that button anymore. But notice that the score is going up. That's not us shooting enemies. In fact, right now for testing purposes, that score is basically telling us the time since the game started. So the game's been running for like 34 seconds now. If I click the settings button, nothing happens, and that's because I didn't set up the button yet. So let's go set that up right now. So remember those 4 steps. Create a UI object in the scene, write a script to call when the UI is operated, attach that script to an object in the scene, and then link a UI element to that object with that script. So we just did step 1. We did step 2. Write the script. We did step 3. Attach the script to something. We're about to do step 4. Link UI element to that object with the script. So I'm going to click on the UI button here. Let me just close this image component so we can see the button component more clearly. There is a thing here on click. So this is for events. This is actually an event system here. I'm going to click on the plus sign here. So now we have a little field for objects. I'm going to drag and drop the controller from the hierarchy into this field here. Now we can call any function that the controller has access to. So any function that is part of the scene controller, and any function that is part of, you can't see it here because my face cam's in the way, so let me just fix that. We can call any function that is part of the UI controller. So that on open settings method that we just wrote, we are now going to call it every time that button is clicked. And remember, that method, all it does right now is print stuff to the debug console opening settings. So now this method is going to be called every time I click the button. And if I do click the button, opening settings. See here? Opening settings. We don't have a settings pop-up window just yet, but we're going to do that next. That's one of the next things we're going to do. Okay. So now our button is working. Let's work on that pop-up window next. So I'm going to need a new image object. So image, and in the image component, I am going to drag and drop. Let me get the sprites here. I'm going to drag and drop this pop-up sprite into this field here. That sprite is way too small for our purposes. However, if I try to resize it, let me try to resize it like this. So if I use the scale tool and try to resize it like this, it doesn't look good. Because we are, as we scale this sprite, we are also scaling the borders. So there is a way to cut this image into 9 pieces and then only stretch everything but the corners. It's called a 9-sliced image, where, as I said, we cut the image into 9 pieces, and as a first resort, we're going to stretch everything but the corners. That way, we can make different sized windows without having to make separate sprites for every size we need. So how do we do that? Okay, so I'm going to select the pop-up sprite and view it in the inspector. I'm going to click on the sprite editor, and if you are working with a 3D project, you are not going to have the sprite editor available. You need the 2D sprite package first. So I'm going to go to Window, go to Package Manager, look for 2D sprite. I'm going to type it into the search bar here. Nothing's showing because I'm looking for all the packages in the project. I want to look for it in the Unity registry. So 2D sprite should be somewhere in here. Let me look for it again. 2D sprite. Here it is. There's a little install button. Click install. Unity importing, compiling, and there we go. We have 2D sprite. So now I'm going to open this again, click Sprite Editor, and now we can edit this sprite. So, see these green handles here? Those are for designating borders on our image. So, I'm just going to drag these sizing handles here so that they are 12 pixels from their respective edge. Or I can just type in 12 for L, R, T, and B border down here that my face cam is covering up. It's over here. Once we have that, I'm going to click Apply, and now we have a 9-sliced image. So I'm going to click on this image again. And we're going to have to tweak a few settings in here. So image type, instead of simple, it's sliced. Okay, so right now it's not quite working, but I believe that's because I just changed the scale on it. So I'm just gonna reset the scale back to 1, 1, and 1. So now if I change the width and height of this, if I change the width and height of this image, it's also going to preserve the proportions of the border. So previously we had that blue border around this pop-up being stretched as well. That's no longer happening here. So now we have a 9-sliced image. There we go. The textbook has us set the size to be 250 wide and 200 tall. I'm not sure how that's gonna work for me, since I have the canvas scale factor to be 2. So I'm just gonna wing it with the scaling, and you can just simply follow along with 250 by 200. Okay, so now I'm going to position. Let me select the move tool so I can move this to be in the... No, I want to move this to the center. So I'm going to set position to be 0, 0, 0 for our image here. Okay. So now we have our pop-up image here. Let's rename it to pop-up. Ah, come on. If I can learn how to spell. There we go. And since this must appear in front of everything else, one thing we should make sure is, in the canvas, there is a loading order, and objects towards the bottom are loaded towards the front. Well, that's already taken care of us here, for us right here. So that's something to keep in mind. Layering order in the canvas is based on how UI elements are ordered in the hierarchy. Things towards the bottom are loaded towards the front. Okay? So now let's add some more code to our UI controller. Serialize field settings pop-up, and I'm gonna call this lowercase s settings pop-up. Okay, I don't have a script for this yet, so that's why it's showing up red. So I actually need to create a headings pop-up script, so I'm gonna have to do that right now. So assets, create C# script settings pop-up. In that script, open up. I only need to add 2 methods to this. Public void open game object that's set active true. And then I can simply just copy paste this whole method, rename it to close, and then set active false. So basically these are 2 methods for opening and closing the settings pop-up by set active true and set active false. Okay, there we go. Next thing we need to do is attach this settings pop-up script onto this pop-up window here. So settings pop-up script, drag and drop onto the pop-up image like this. So I am dragging and dropping it directly into the inspector. It's a little bit hard to see because my face cam's in the way. I'll move it again. Okay, so the pop-up is selected. I am dragging and dropping the settings pop-up here. There we go. Let me just move my face cam down here. Okay, so now we have the settings pop-up here. Actually, the next thing to do is we have our UI controller, and it needs a reference to our settings pop-up. So I'm gonna take the pop-up here and drag and drop it into this field. Okay, now we can modify the UI controller script some more. So let's go back to our UI controller, and we've added a field for the settings pop-up, but we need to add a few more fields. No, not fields, a few more methods. So I'm gonna add a start method. I'm gonna say settings pop-up dot close, because the settings pop-up should not be visible until we click on the settings button. And on open settings, we're gonna add settings pop-up.open. There we go. So now I save that. I'm going to run the code again. So when I run this code, that pop-up should, well, hide. It should now be it should be hidden when I start the game, because it's calling the start method, which is called at the start of the game, obviously. So let's click the settings icon, and there we go. It pops up, but I have no way to close it. I can't close it. Okay, so I guess it's time we start fleshing out the pop-up itself. So I'm gonna zoom in. And now we're gonna add a few things to the pop-up window itself. First, I'm going to add another button, and it's going to be a close button. And I'm actually going to make this a child object of the pop-up. It's a little bit hard to see right now, but there are anchors on the new button that we just added. If I change the anchor to be on the upper right hand, it's not the upper right hand corner of the canvas, but rather the upper right hand corner of the pop-up. That way, if I ever want to change the size of the pop-up window, the button will still be anchored to the upper right hand corner, much the same way the settings button and these two other elements here, they'll stay in their corners regardless of how I resize the scene view. So this button here needs a different sprite. So I'm going to change the sprite. I'm going to drag and drop the close sprite into the source image field. And then I'm going to have to click set native size. But on. We don't want that. Let's actually change the text on this so it's a little bit smaller. Say, just change it to be something a little bit smaller, and yeah, change the font size to be something smaller, and then change the text so it's close. You might also want to change the font color also. Right, so let's take this close button and position it to be in this corner here. Okay, remember how the close button has this on-click event here? Well, that list is also empty, so I'm gonna add something else. The pop-up here has a close method, so I'm gonna call that. So I'm gonna drag and drop the pop-up from the hierarchy into this field here, and then I'm gonna select the setting in the settings pop-up. I'm gonna select in the settings pop-up here. I'm gonna select the close method here. So the idea is, if I open the settings pop-up, I'll be able to close it again. So, open, close, open, close. It works. Alright, so let's fill out the rest of this pop-up window. We need two things. Well, actually we need three things. I'm gonna need a slider, and that must be a child object of the pop-up. Also, I need to move the slider so it's a little bit lower down here. Okay, now I need another UI element. Input field. Make that a child object of the pop-up also. Adjust the position so it's a little bit above the slider. And I also need another text object. So UI text TMP, make that a child of the pop-up. And I'm gonna make the text small. So for me, I'm gonna change it to 16. I'm also going to change the width and height of this to be as like this. So for me, I'm gonna change it to 25 units and maybe 150 units like that. I'm gonna drag it to be right above the slider. That way, actually no. Yeah, I'm gonna drag it to be right above the slider. I'm gonna change the font color to be black. And I'm gonna change the text to say speed. There we go. Now we have our text pop-up fleshed out. But there's still no code attached to any of these things. So, let's go back to our settings pop-up and add a few more methods. Actually no, it's not it's the settings pop-up script that we're going to add a few more methods, not the UI controller. Right, so we already have an open method and a close method. We need to add two more methods. On submit name, string name, and I'm going to say debug.log name. And then I'm going to add another method, public void on speed value float speed. And I'm going to say debug.log $ quotation mark speed colon and then curly brackets speed. This way, if I make any changes to the input field and to the slider, they're gonna show up in the debug console. Oh yeah, there are a few more settings that I want to change on the slider. Let's go to that slider. And this slider, if you recall, is going to change how fast the player is going to move, and it's also going to change. It's basically going to change. It's going to change how fast the enemy and the player are going to move. So I want the minimum value to be. We're going to leave that at 0, and we're also going to change the max value to 2. We also have the option to use whole numbers if we want. I'm just going to leave it as floating point values. So if you go back to the slider, you have several options. Min value 0, max value 2, whole numbers that can be toggled, and the current value is over here, down here. Okay, so let's select our input field, and if I scroll all the way down here, on End Edit, I'm going to click plus. I'm going to drag and drop the pop-up into here, into this field here. And now I'm going to select the now that I have the pop-up in here, I'm going to select the onSubmitName method. But there's a problem. There's onSubmitName up here, but there's also another one down here. You want the one under the dynamic section. So it's the one up here, not the one down here. If we select the one down here, an extra field's gonna show up here, and what that does, it's going to pass in a predefined string for us. So it's not, so whatever was written in here, it won't show up. So we instead actually want settings pop-up on submit name, but it's the one under the dynamic setting. No, the dynamic section. So on submit name, there we go. That way, whatever we type, it's gonna be passed in to the onSubmitName method. It's gonna submit. It's going to this onSubmitName method. It's going to be passed in whatever text was typed into this text field here. Alright, well now let's go to the slider here. Similar deal. There is an onValueChanged event here. I'm gonna click on the plus here. I'm gonna drag and drop the pop-up into this field here, and I'm gonna select a method that's under the settings pop-up section here. And once again, it must be under the dynamic setting. It has to be under the dynamic section. Right, there we go. That way, whatever speed value was set on the slider, it's going to be passed into this method here, and we're gonna print that to the screen. In fact, let's try it out. Okay, scores sticking up, the number of seconds since the game started. If I open this up, I'm gonna type in random text, and in the debug console, it printed out random text as my name. That's an odd name. Also, I can change the speed slider, and if I do that, it's going to print that updated value to the console also. Alright, so it works. Not quite though. We need these values, we need the speed value to affect, we want this updated speed value to affect the player and the enemy. And also what we want to have happen also is, every time the player shoots down an enemy, it's going to increment the score up here. So that's actually the next thing we're going to do. And how we've been setting up communication between game objects so far is we would have fields on our scripts that would have references to other scripts. And that is okay for a small project like this, but for larger projects, we're going to need something a bit more robust, so that way, even if one system breaks, we can still work on the rest of this. We can still work on everything else. We want an event system. So it turns out I had made this to be its own set of slides, and this next set of slides, I basically breezed through the entirety of these slides. So we've covered everything that these slides have to offer, and once again, these slides are also available on Canvas, as are these next set of slides. Part 2, which is basically all of section 4 of chapter 7. Let's look at this too. Start looking at this. Okay, slideshow, monitor, primary monitor, from current slide. Okay. So, as I said, we have the UI set up, but it's not really communicating with the rest of the game at all. We can get communication set up by having fields where we drag and drop other game objects into those fields, and then we'd have references between game objects, and they communicate between one another this way. And this works for small games, but for larger games, it's probably a bad idea. Okay, so basically there are big disadvantages. This means of having game objects have references to other game objects makes all these game objects dependent on one another. This makes everything tightly coupled when we want things to be more loosely coupled. So if they're tightly coupled, if we are missing a reference to one game object, then the rest of the game is not going to work. We want, as I said, we want a means of communication between the UI and the main game, such that even if one breaks, the other can still work. So we are going to create a messenger event system. So objects can register to listen for specific events. For example, there's going to be an event for when the user shoots down an enemy. The UI is going to subscribe to that event, and it's going to receive a message for whenever the player shoots down an enemy. When the player shoots an enemy, it's going to broadcast an event that's basically, hey, the player shot down an enemy. And that's going to be broadcasted to whoever is subscribed to the enemy is shot down event. The UI is going to be listening for that event. It's going to receive a message because it's subscribed to that event. It's going to receive a message, hey, the player's shot down an enemy. And then the UI can simply update the score. So, we don't need to write any code because there is a script on the GitHub repo that has everything already done for us. So what I'm gonna do is I'm gonna copy paste all of this code. Copy. And then in the project, I'm gonna create a new script called Messenger. I'm gonna open the Messenger class. I'm gonna open the Messenger script, delete everything, and paste all the code that I had copied from the GitHub. Some Unicode characters in this file could not be saved with the current code page. Do you want to resave this thing as, if you get something like that, hold on. Okay. Save with other encoding, it's because there are some non-ASCII characters in here, so we have to take care of that. Okay. Advanced saved options, I guess an easier thing to do would just be to go back to that, go back here, and just download. Okay, let me just make this quick. I'm gonna download this entire script here. So, okay, it's downloaded. I'm gonna go to my downloads folder. Here it is. I'm just gonna copy all of that, close that, and then paste it into my Messenger script that is part of the project. So now all of that is saved, and it's hopefully without any weird characters as well. So yeah, we can just download the whole script and just copy paste the code. Okay, now we have the Messenger system all set up here. Now, this script is not attaching to anything. In fact, this script is composed of multiple classes, static internal class, and then another class in here called Messenger, and then another one called Messenger T, and then Messenger TU, and then like Messenger TUV. So, yeah. This script does not attach to anything. None of the classes in here inherit from mono behavior. So this is a standalone script, but we can still use it with the rest of our project. Okay. We're actually at the home stretch right now, so right now we have the Messenger system all set up, but we need one more script. I'm going to create a new script called game event. I'm going to delete everything from that script, and I'm only going to add in like 3 or 4 lines of code. Public static class game event. Public const string, and then in all caps, enemy hit equals. Also in all caps, enemy hit. And then I need another string like that. So I'm just gonna duplicate that line. That was Control D, by the way. I'm gonna rename it to speed changed, and the text for that is also speed changed. There we go. This script does not inherit from mono behavior either, so it's also not gonna attach to anything, but we can still access it. We can still access it from all of our other scripts. Okay. Let's now edit the UI controller so it uses this event system. So it's going to use this Messenger event system. I'm going to add another field. private int score. I'm going to add to the start method 2 more lines of code. Score equals 0 and score label.text equals score.toString. Okay, after that, I actually need to add in 2 more methods. Actually, no. On top of that, I need to delete the entirety of the update method because I don't need that anymore. The only reason we had that is to test out the UI. So now we're gonna have the UI work as intended, where it reports the number of enemies shot. Okay, so now I'm going to add in. I'm gonna add in 3 methods. So the first one is private. Okay, maybe like this. On enable, and then I'm gonna write in messenger.add listener game event dot enemy hit, and then I'm gonna pass in another method on enemy hit. Now this isn't working because the on enemy hit method doesn't exist yet, but maybe let's just write that first. Private void on enemy hit. And then I'm going to write in the following code. Score plus equals 1 and score label text. Score label.text equals score.toString. So I'll just copy and paste that 1 line of code. There we go. So now we have the on enemy hit method. So now I'm going to add 1 more method to this. On disable. Remove listener game event dot enemy hit on enemy hit. So what's happening here? Well, you can think of it as subscribing to a newsletter. When this script subscribes to the enemy hit newsletter, it's gonna basically wait for a letter that says the enemy has been hit. From there, the event is going to be broadcasted, and when it does, it's actually going to call the on enemy hit method. And when that happens, the score is going to update by incrementing by 1. Okay, so that's the first part. The second part has to go into the race shooter. So now I have to go back to the race shooter. There is a line of code that starts with if target does not equals null. It's this line here. I have to broadcast the event. So there's broadcasting and subscribing and listening for events. Oh yeah, also when the script, if that instance of the script is ever deleted, it must also unsubscribe, or else we're gonna have like null pointer errors or something like that. Anyway, let's go back to the race shooter. And in here, I'm going to add messenger.broadcast game event.enemy hit. So when the user successfully hits an enemy, it's going to broadcast that event. An enemy has been hit. Anyone who is subscribed to that event will more or less get a message that the enemy was hit. For our UI controller, that's going to end up calling the on enemy hit method, which is going to increment the score by 1, and then it's also going to update that to the UI. Alright, let's try that out. So here's an enemy cube. Shoot it down. And the score was incremented by 1. So it works. 2, 3. And it's gone. That enemy probably went into another room, and I can't... Where did that enemy go? Okay, so let's... Okay, so our enemy went into a different room, so here it is. So if every time I shoot down an enemy, that counter is gonna go up by 1. Right, so our event system is working. So, now we're going to modify... Okay, so this is the last part of this exercise here. Are you going to submit anything related to this? I'll let you know. I think most likely your next programming assignment is going to involve more about Chapter 9. The reason why I'm showing you this event system because it might be a good idea to implement this instead of having, for example, updating the score every time, trying to update the score even though there's nothing to update every call of the update method. So yeah, I'm showing this to you as an alternative to changing the score every call of the update method. So I'm gonna go to the wandering AI script and I'm gonna make a few more changes here. First, I am going to add a public const float base speed. So I'm going to put in here. So this is going to be code related to changing the speed slider. Okay. So now we have a base speed of 3. I'm going to add in 3 methods here. The first one is on enable, messenger, and then angle brackets, float, because this is going to be an event where a parameter is going to be passed in. No, an argument is going to be passed in. So messenger float dot add listener, and then in the parentheses, I'm going to say game event.speed changed, and then on speed changed. Okay, that's not working because the on speed changed method, that doesn't exist. So I'm gonna have to write that next. Private void on speed changed, and then speed equals base speed times value. Oh yeah, I forgot. Float value. There we go. So now, when this method is called, it's going to change the current speed to be the base speed times this multiplier value here. Okay, one more method to add, and that is on disable. So when this wandering AI script is disabled, it's going to unsubscribe from the event system. So I'll just copy paste this entire line of code, and instead of add listener, it's remove listener. There we go. So this is going to change the speed of the enemy. Also, we're going to do the same thing with the player. So I'm going to have to go to the FPS input script. Here it is. So, I'm going to add public const float base speed equals 6f. And then I'm going to add, similar to the wandering AI script, I'm going to have to add 3 methods. But I think I can just get away with copy-pasting everything. So I'll just copy these 3 methods from the wandering AI script, and then I'm going to paste them into the FPS input script. There we go. Oops. So, both FPS input and wandering AI are subscribed to the speed changed event. Every time the speed changes, it's going to broadcast that event to everyone who is subscribed to that event. And they're also going to get the new speed value. When that happens, the player and the enemy are going to change their current speed. Okay, but something needs to broadcast that event. So here's the last thing we have to do. In the settings pop-up script, there was a onSpeed value method. So here I'm going to write in messenger flow dot broadcast game event dot speed changed speed. So onSpeed value is called every time I change the slider value. When that happens, it's going to broadcast that event and also send the new speed value to everyone who is subscribed to the speed change method. Everyone who is subscribed to that method, everyone who is subscribed to that event will then get the new speed value. So let's try it out. So as we saw previously, the enemy shooting thing where the score goes up every time we shoot at an enemy, that works. But also now let's change the speed. We're moving faster now. So where's the enemy? Okay, how fast can we go? Okay, so that is the maximum speed. Okay, so it is working, but there is one caveat to this. If you can find the current enemy in this, I don't think it's moving any faster. But I am. Okay, so there is one slight hiccup with this script. New enemies are basically gonna spawn with the default speed value. In fact, their speed value will not update until I change the speed slider like that. And then the enemy's speed will update. So it's a little, so the textbook makes it an exercise for you to try to tweak the code so that when the speed value is changed, it's going to update the enemy speed on the fly. So that is a little bit of an exercise that you can try out on your own. So try that on your own. I'm not really going to assign that, but just try it out. See how far you can get with having it so that the enemy speed is changed on the fly. Not when the slider is changed. So that is one little flaw with how this code is written, but yeah, it's something that you can try out to try to see if you can fix. Alright, so that's going to be everything about setting up a UI, as well as setting up an event system, a messenger event system, that acts as a middleman for communicating information from the main game to the UI and vice versa. Alright, so that's going to be it for this chapter. Follow along as much as you can. I'm not sure whether this is going to be assigned for homework for those of you in CSE 4010 sections 1 and 2 spring 2024, but I guess try this on your own and see how far you can get, and then we'll talk about more, we'll address this more in class later on. Alright, that's going to be it for this video, and try it out, and we'll go on from there. Alright, thank you for watching. See you later.